Welcome back everyone, Patrick here, moving on to another word problem. This one's going to be pretty cool, dealing with quadratics and completing the square. So we're told that a parabola has a y-intercept of 1 and that it also passes through the points 3 and 16 and then -1, -16 over 3. Given that information, we have to find the vertex. So this one's pretty cool. What we got to do is first take the characteristics. So notice that we're given 3 points on the parabola, and we first have to find an equation for the parabola, and then once we have an equation we could find the vertex. Now we have a couple of equations to choose from: standard form, vertex form, factored form. Eventually we're going to have to get the vertex form in order to get the vertex, but the question is which one is best to start with. And I feel like with the information that we're given, especially because we're given the y-intercept, it's best to start with the standard form, because the y-intercept, we know it's always going to be the c value in standard form, right? Because the y-intercept, the x value has a value of 0. So this is 0, this is 0, so y is just equal to c. So when they say a y-intercept of 1, well, right away, we can just plug in 1 over here. And then notice that we only have 2 unknowns to solve for, and we could use the 2 points. If we use vertex form right away, we can if we want, or we could try to at least. But the problem is that that 1, the y-intercept of 1, we can't just plug in right away for here, for example, because this k value, that's the y value of the vertex, remember. It's not the y-intercept like the c value is, right? So in order to use that, we would have to actually use the full coordinate 0 and 1, and then 3 and 16, -1, -16 over 3, and we would have 3 unknowns, the a value, the h value, and then the k value to solve for. So it would be more algebra. You can do it that way if you want to. It's just going to take you a little longer to do. Versus here, with the standard form, that y-intercept of 1, we could just plug in right away, and now we only have 2 unknowns to solve. And we can solve for those 2 unknowns, the a and the b, by plugging in those 2 coordinates. So let's first plug in 3 and 16. So we would plug in 16 for y, so we'd end up with 16 equals a, 3 to the power 2 plus b times 3 plus 1. So we'd end up with 9a plus 3b plus 1 like that, and that's 16. Then we could simplify this. Let's bring the 1 over. 16 minus 1 would give us 15. Then we got 9a plus 3b. We can leave it like that, but then if you notice, we can actually simplify this further, because notice everything can divide by 3 smoothly. That's not always going to happen, but in this case it is happening. So why not just simplify everything if we have the opportunity to? So 15 divided by 3 is 5, 9a divided by 3 is 3a. These 3's cancel out, we're just left with a b right there. So that's one of our equations right there. This equation and this equation, they're the exact same thing. So you can leave it like this if you want and use that. You would still get that same a and b value at the end. But if I see an opportunity to simplify, usually I take it. So that ends up being our first equation. And then the second equation is going to come from this point. So if we use this point, -1 and then -16 over 3, we plug in -16 over 3 for y right here, and then we got a -1 squared plus b times -1 plus 1 like that. So this one's going to be a little bit more complex because we're working with a fraction, but it's actually not bad because we can just end up multiplying everything by 3 to get rid of this denominator. But let's first do this algebra. -1 to the power 2 is 1, times a is just a, b times -1 is -b, and then we got a plus 1 like that. So you can leave it like this, you can bring the 1 over and then get another fraction here. What I'm going to do is I'm actually just going to multiply everything by 3. right? You could divide everything by a certain number. You could also multiply everything by a certain number. It's going to keep that equation the same. It's going to change the format of it, but it does keep it the same as long as you're multiplying everything, all of the separate expressions by that same value. And the reason why I'm multiplying by 3 is because that 3 is going to cancel out. So we'd end up with a negative 16 equals 3a minus 3b. That was a plus 1, right? Yes, plus 1 times 3, that would give us plus 3 like that. Then from here, simplifying this, we could bring the 3 over. Negative 16 minus 3 would give us negative 19. And then we got 3a minus 3b. Then over here, notice that this negative 19, it doesn't divide by 3 smoothly. So I'm actually just going to leave it like this. It's not going to simplify further. You can divide both of these by 3 and then this by 3. You'd end up with a fraction here, but then you'd have the a and the b alone, which is nice. I'm just going to keep it like that for now. So what we got now is 2 equations. So let me write those. So we got 5 equals 3a plus b. That's equation 1. And then the second equation is negative 19 equals 3a minus 3b. And so now we just take these 2 equations. We want to solve for a and b, and we can do that either with substitution or elimination. I'm going to use substitution just because this b is by itself. Personally, I prefer substitution, but you could also do elimination. Notice that the 3a's are the same, so you could actually subtract both of these, and that would get rid of the 3a terms, and you'd have everything in terms of b. I'm just going to use substitution. So I'm going to isolate for this b. I'm going to keep it on the right side, bring the 3a over. So we'd have 5 minus 3a equals b, and then I'm going to take that expression for b, plug it in here. So we'd end up with negative 19 equals 3a minus 3 bracket 5 minus 3a, like that. So we end up with negative 19 equals 3a minus 15 plus 9a, like that. And then let's bring this over. So negative 19 plus 15 will give us negative 4. 12a, divide both sides by 12. And so we end up with a negative 1 over 3 like that. So we got the a value, and then to get the b value, you could plug it into either one. I feel like the easier one to plug in is this one over here. The b is already isolated. So I'll plug in negative 1 over 3 for a. I'll have 5 minus 3 times negative 1 over 3. We'll have 5 plus 1, which would give us 6. So the b value is 6. So we got the a value, the b value, and we got that c value of 1. So we end up with that quadratic, a full expression for the quadratic in standard form, like that. So that ends up being the quadratic right there. We're not done though, because we have to find the vertex. So what we could do is we could take this standard form, complete the square on it, change it to vertex form. So in order to do that, I'll actually do that on the side over here. So we end up with negative 1 over 3 x squared plus 6x plus 1, like that. So we can take out a negative 1 over 3 from these first 2 terms. Now 6, let's do this on the side. 6 divided by negative 1 over 3, it's like 6 over 1 divided by negative 1 over 3, which would be like 6 over 1 times negative 3 over 1, which would give us negative 18. So we'd end up with x squared minus 18x plus 1, like that. So be careful with these fractions, maybe do some algebra on the side, and then you could check it. I take the negative 1 over 3, redistribute it in the bracket, and notice I'll end up with negative 1 over 3 x squared. Negative 18 times negative 1 over 3 gives us positive 6. Right? So that is the correct factoring right there, taking out that factor from only the first 2 terms. Now what we do, we take that negative 18, we divide it by 2, then we square it, so we end up with negative 9 to the power 2, which would give us 81. So we end up with negative 1 over 3 x squared minus 18x plus 81 minus 81 plus 1, like that. Then what we do, got to take out the negative 81, got to multiply it by the negative 1 over 3 that's in front. So we end up with negative 1 over 3, x squared minus 18x plus 81. Negative 81 times negative 1 over 3 would give us positive 27. And then we got the plus 1. Then this over here, always going to be a perfect square trinomial. That's going to factor into x minus 9 squared, right? It's always going to be half of that number. That goes over here. Half of negative 18 is negative 9. 27 plus 1 gives us 28. So this quadratic and this quadratic, they're the exact same thing. This is in standard form, which we got from the information given. Then we converted the standard form to vertex form by completing the square. And then from there, we could tell what's the vertex, 9 and 28. And so that ends up being the final answer to this question.